Cool, that's a good conversation. So I think I can take control of the screen. Hey, good morning, everyone. Thanks for taking time to watch what we have done in this sprint. Like Josh just mentioned, so in this sprint, we are not only building some infrastructure code, but also building some simple application that can be used to test our infrastructure code. We consider two types of user cases. So the first one is more like the new development. So sometimes user may not have any legacy system, and they just throw some requirement to us. So in that case, I would say the architecture that Josh proposed using some API gateway, Lambda function, or DynamoDB, those fancy stuff. Those things could be a better option. So those serverless services, I would say, is easier to maintain. It could be cheaper, and also it can be easier to interact with other cloud services. Uh, but we also have some user case like NTS. They already have a legacy system, and we cannot get a clear requirement from them. So they basically just throw those old code to us and ask us to make it up and running in cloud in, I don't know, 2 hours. So in that case, it's almost impossible to read their code line by line and try to mimic their logic in the new way. So instead, a better or a more realistic way will be try to modernize their application a little bit and make it run in application. So that is the one that my focus in this sprint. So we have this simple app in 3 tiers. We have the front end hosted in S3 using JavaScript, and some people think that S3 static hosting option, it just hosts the static like pictures and some statement, and it's not true. That is a type of static, but with JavaScript we can also do some interaction with backend. We can call the API and try to bring some data back. So it's quite flexible. And then in the middle tier, I use the .NET Core to do the API work. So it's hosted in ECS Fargate cluster, and to send the database request to gather data. And the data is actually coming from the RDS use SQL Server engine. And I would say that is a pretty common a design that we can particularly compatible with a lot of application cases. So, and we also have the flexible to easily change, let's say, the database from SQL Server to Postgre or MySQL. So it's just a matter of a few parameters in our infrastructure code. And also for the middle tier, so I'm a .NET developer, so I'm quite comfortable with .NET, but we can easily switch to Java or Python, any type of language. So those things can easily be run in Docker and can be running in Fargate as well. So I can do a quick live demo here. So my front-end code is hosted in this bucket. And as you can see, it's already been built into those HTML and JS files. So my source code is a TypeScript, but after the pipeline runs, so we compile those, I cannot use the word compile, but just build those things from advanced JavaScript to those standard one. And then those things can be easily run in the browser. So we call it static because we don't rely on a server like a .NET framework or a Java a runtime to run. So all those things will be executed in the browser only. So we call it static. But if we go to the static website link here, to bear with me. I know it's ugly UI. I'm not good at it, but that's also the beauty of this design. So no matter it's fancy or ugly, so those front end code can all fit into this model. So we can query those data from the database easily, and we can also try to, let me add a new record. We can say add let's say BD, add a new record. show up. So it can do almost similar thing as our traditional ASP functions. And for the middle tier, we have this ECS cluster hosted in Fargate. So we have multiple tasks based on our need, and those things are hidden behind a load balancer. So as a user, I will not hit the ECS cluster directly. Instead, I will just access a load balancer, try to access my API, and I have those functions defined here: get department, add department, or add. I can easily query the result from here using this tool. So as a backend developers, even I don't have the front end, I can still test our backend code without any problem. And you may ask, like, in this case, why do I consider a load balancer in the middle? So what this guy does, so the thing is, if I drop or create new tasks, so this IP address may change. So I may get each time I may get different IP address returned. So as a user, I want to get a permanent address to access. So that's the benefit of this load balancer. I can have this DNS name associated here. So therefore, my API or my entry point to access those backend is always permanent, like I showed here. Any questions so far?
No.
Okay, cool. Yeah. So with this model, so what we try to achieve is keep adding the new components to this architecture, saying we can consider adding some cache logic between application and RDS to accelerate the access, and we can also add some, let's say, CDN to benefit the user from all over the world. So we will keep adding the components to our application, and also improve our adding new stuff to our infrastructure code, make them match. And whenever a customer asks a case or through some requirement to us, we can easily adjust our application, try to take a portion of our whole pipeline and try to build the environment for them. So in terms of the next step, those services will be created through CDK rather than the AWS console. So we'll try to build those services as quick as possible. And also we want to add some new services to make this application more fancy. So if there's no other questions, I will pass it to RPA team. Thanks for your time.
That's great, Mo. Thank you. By the way, yeah, you mentioned that, kind of like, the front-end developer. Same question. Please try to do some research and play with Copilot and see if it can help you to create a better front end. And if so, I would love to see your results in the next demo.
Yeah, cool. Good suggestion. I hand it over to RPA team.